All right, so let's talk about this piecewise function that you see right now. Don't worry about this equation. It does look a little bit complicated to you right now, but let's just focus on this graph and analyze it. So we always start with the domain. So domain. Domain represents, if you remember, all the possible values of x, right? So here we noticed we have, look at the behavior of your graph. As x gets smaller and smaller and smaller, what happens to your graph? It looks like it's going down, right? On the left side, it's decreasing. And what happens as x gets bigger and bigger and bigger? We have another arrow here, so that means your graph is increasing. So it doesn't really stop, right? Doesn't stop on the right side, doesn't stop on the left side. So we would say this function is defined at every single point, at every single x value. But wait a second, did you notice you have this little, you see this little circle? It's not filled in. So that means your function is not defined at that value, which is x equals to 0. But every, other points, your function is, your graph is nice and smooth. We don't have any breaks, no gaps. So we would say the domain of this function would be all real numbers except for x equals 0. So how do we write that? We need to express it in interval notation, please. So we would say, we move left to right, if you remember. So we say negative infinity all the way to 0, and that's when you stop. Obviously, you don't want to include x equals to 0, because that's where your function is undefined, union. And then another piece, it would be from 0 to positive infinity. So now we're done. Let's talk about the range. The range would be all the possible y values, right? So let's see. Well, your graph on the right side, it goes up. So y gets bigger, bigger, and bigger, and bigger. The left side, look at your left side. On the left side, your graph is going down. So the y values are getting smaller and smaller and smaller. So it looks like every single y value would be okay in this case. But there's one spot that worries me. And that's that, right? Because when y equals to 0, well, and x equals to 0 at that point, your function is not defined. So you know what? It looks like it's going to be the same thing. So now we're going to say it's negative infinity all the way to 0. You don't want to include 0. And then from 0 to positive infinity. Now we're done with domain and range. Let's talk about the third case where we have to mention all the zeros. If you remember, zeros are the x values for which f of x or y equals to 0. So in other words, the parts where your graph crosses points, where your graph crosses the x-axis. So let's see. Well, it looks like it crosses the x-axis at this point, which is negative 3, and at 0. But I can't call this point right here, I can't call it the 0 of my function because my function is not defined at that point. So even though it looks like it goes through the x-axis at that point, but your graph breaks. So the at this point, I would say my zeros are, well, you know what, x equals to negative 3 for sure, that's obvious, but I'm not sure where it crosses the x-axis here. So let's pretend it crosses the x-axis at negative 6. So on your future test, obviously, I'll make your graph clear, and you will be able to tell what the zeros are. Now, I don't really like it this way, so because x equals to negative 3 could be anything, but we're talking about the zeros. So I want you to say, instead of that, I want you to say 0, comma, oops, sorry, we're talking about zeros. So x comes first, the negative 3, comma, 0. So that would be your coordinates, the coordinates of your first 0, or sometimes we call it the root. And then the second one is x equals -6. I don't like that, so you're going to say it's -6 comma 0, because the y value is 0 at that point. So now I'm good. So these guys are my zeros. So the next one, increasing, decreasing. Well, again, remember, you always move left to right. So as I move left to right, so look at the behavior of your graph. So obviously it's increasing, right? It's going up. Oh, you get to this point, and then it starts decreasing. So it's kind of hard to tell here, but let's say it's -5. So your graph starts increasing. Well, you can't say at a certain point, right? Because it doesn't really start at a certain point on the left side. So you're going to say negative infinity all the way to -5. Now, you don't want to use brackets because at x equals -5, your graph reaches the maximum point. You see that bump right there. But I can't say that at x equals -5, my function is increasing. No, it's just that turn, right? So don't include this point, this value, this -5. Don't include it, please. So then what happens next? So continue. You're moving left to right. So as you move left to right, after this, your graph is going down, right? Up to this point. So that would be decreasing, but we're talking about increasing. So then we're going to start here. Well, let's say it's -1.9, because it's not really -2. You see that? So it's somewhere here. See this minimum point? So I would say -1.9. It's very close to -2. So starting there, so you say from -1.9, and then let's see, it's increasing. Oh, it looks like when you get to this point, you're not going to go down. You're going to continue, going up. So your function is increasing the whole time after this point. But I can't say from -1.9 to infinity. That would be wrong. Why? Well, because my function is not defined at x equals to 0. So I have to exclude that point. So I'm going to say from -1.9 to 0. You stop there. Obviously, you don't want to include that value. And then union, see, we have to break it into separate pieces. And then from 0 to, and it doesn't end at the certain point, so it just keeps on going, right? So to infinity. Now, what happens there? You say every single interval we mentioned, our f of x is increasing. Now, decreasing. Well, you can see that green the line right here. So that shows you where your graph is decreasing. So left to right. So you're going to say -5 all the way to, and remember that point right here? We said it's -1.9-ish. So you stop there. So that's the only piece. That's the only piece where your graph is decreasing. So you say decreasing. F of x is decreasing. Maximum, minimum. I didn't say the highest or the lowest point on the graph. So those points we call absolute maximum, absolute minimum. But don't worry about that terminology yet. So minimum, maximum. You see those bumps. So your function is, it's your graph turning right there. So it goes up, hits that point, and then it goes down. So this guy right here would be your maximum. And by the way, you can always graph it on your calculator, and we will talk about it later, and see what the actual the value is on your calculator. We're estimating here, and remember we decided that we're going to call it x equals to -5. So you say the maximum value would be, well, value. It depends on how they ask you a question. So I would want to see the coordinates of that point. So in that case, you would say it's -5, comma, looks like y is 1. So -5, comma, 1. Minimum point would be right there. So it's x comes first, so it's -1.9, comma, and y looks like it's -1. And that's it. I'm not sure if you're thinking about this point right there. I can't really even think about that point because it doesn't really exist. The function is undefined. So I don't even care whether it looks like a maximum or minimum. It doesn't even matter because the function doesn't exist at that point. But it's not actually minimum, or even if the point was, that circle was filled in, the function is increasing at that point. In this case, it's undefined. Okay, now number 7 and 8. So last two things we need to talk about. X values for which f of x is greater than 0. So I'm going to actually erase this so that I have more room. So let's see. F of x is increasing. So it's not increasing, I'm sorry, it's number 7. F of x is greater than 0 on what interval? So when it says f of x, well, that's the same as y, right? So it's greater than 0. Every single y value is greater than 0. So that means you're just looking at what part of your graph, where it's above the x-axis, right? So again, we're moving left to right, remember. So when you're going, let me erase this. And all right, now I can do it. So we're moving left to right. So when you go, you're going this way, right? And the function is increasing, but you know what? When you get to this point, which is -6, you hit the x-axis, you cross the x-axis, and then look at that bump. Your graph is above the x-axis now, right? And what happens? No matter what your x value is between -6 and -3, the y value is always positive. For example, when x is -5, go up, hit your graph, what's your y value? Positive. X is -4. Go up, hit your graph, what's your y value? Positive. So any point you pick between these two x values, -6 and -3, the y values are always positive because your graph is above the x-axis. So we're going to say f of x is greater than 0 on, well, we decided it crosses at -6. So we're going to say from -6 to -3. Just that, right? So far. Now, let's see. How come I didn't use brackets? Why didn't I include -6 or -3? Well, be careful. Because if you include the -6, that means you are considering that value. You are considering that value, and you're saying, oh, when x is -6, my y value is greater than 0. But that's not true, because when x equals to -6, the y value at this point is 0. And we don't have an equal sign here. It just says a strict inequality, and it says greater than. So that's extremely important. Now, if I had an equal sign, if it said f of x is greater than or equal to 0, okay, then you would include the -6 and -3. So remember that. All right, let's continue. So what happens after that? So it's above the x-axis here, but look, now it's below the x-axis, right? So each y value here is negative, so we don't want to include that part. Okay, so we start at 0, which is a bad point, bad value. The function doesn't exist there. But then look at that piece. No matter what your x is, x gets bigger and bigger, and y gets bigger and bigger, and your graph is above the x-axis, and every single y value is positive. So you're going to say f of x is greater than 0 on -6 to -3, and 0 to doesn't end, so infinity. Done. Now, the last one, actually, I want to do this. I want to find out on which intervals the f of x is less than or equal to. Now I want to say or equal to 0. Well, one more time. So let me just erase that again. We're moving left to right. So it crosses, we decided, at -6. So look what happens as you move left to right. So your graph is, you see that piece? It's below the x-axis. So that means each y value is negative. So that means you say, well, you don't start at a certain x value because of that arrow, right? So you say negative infinity all the way to -6. Okay, now I'm going to include the -6. Why? Because it says or equal to 0, and at x equals to -6, the y value is 0. So that's why I'm including that point. And union. And let's see what happens then. We decided that this is, we already discussed that, this bump, you see, it's above the x-axis, so the y value is positive. Okay, now look here, between -3 and 0, your graph is below the x-axis, and the each y value is negative. Now you do want to include -3, right? Because it says or equal to at -3, x equals -3, the y value is 0. Now be careful when you get to 0, even though it says or equal to, you don't want to include the 0. How come? Oh, because your function is undefined. It doesn't exist at that particular point. That's why. And then what happens after that? And after that, your graph is above the x-axis. So that's about it. So now you need to try another graph, and I'll give you another graph, and I'll ask you to do exactly the same thing. I'll ask you to describe, analyze that function, that graph, and answer all those 8 questions. The questions are the same.